Hi everyone, back again with new concept. So nowadays we all know that RAG is very popular framework and retrieving is a very major step within the RAG. So how it retrieves? So it will do different kinds of search in vector databases to retrieve the data. That we all know, but what kind of searches it is? So one is a matching the user's keyword with what are the keywords present in the vector store. That's called a keyword search. Second is like finding out the which is a similar or which is nearby vectors, that is called as vector search. Third is semantic search, and fourth is a hybrid search which combines the vector search and keyword search. So now if you see there are two searches, like one is a vector search and one is a semantic search. What way it differs each other? So that is the concept of this video, which I was trying to explain. So as you see in the picture, it's both are the supermans in similar way. Both semantic search and vector search are same, but they differ in very slight way. So that's what I was trying to tell with this picture. And yeah, now we are I'm talking about vector search and semantic search. So to understand what is a vector search, first we need to understand what is a vector. Vector is something which represents the data in the form of a direction and a magnitude. So let's say A is a magnitude and there is a direction for A. So if there are a lot of vectors, so then this complete space which is helping to represent these vectors is called as a vector space. So when you are talking about the vectors, you will be dealing most of the time with the vector space only. So first thing is like you need to understand what what exactly happening within the vector search. So there is a user who sends a query like something like, "Hi, how are you?" So now what happens? First thing we need to understand the basic how this text is converted into the vector. So let's say hi is one word, how is one word, are you is one word. So both like let's say there is a popular method to convert this into the vector. So one is like bag of words. So there is TF IDF. So one way is you can consider the BUT models or so basically these are like these will be creating the sparse vector. So which means like most of the times the vectors will be having zero. So this is like condensual, I mean dense vector because most of the context will be converted into the like a lot of different values rather than having the zeros most of the times. But yeah, let me tell about the bag of words. So it will help you to understand how the normal text is firstly converted into the vector. Then again we will understand what happens within the vector set. So you see, hi is one word, how is one word, re is one word, u is one word, and you can consider if there are few other words you can consider on the zero. So it can be represented in this form. So this is the vector right now. So this is how the normal text is converted into the vector. So now we understand how it gets converted into the vector, but now we'll dwell into how the vector search actually happens. So when you see user will send the query. So this converts into the vector. So now there is already a vector store which contains lot of vectors. Now this vector should be matching with these vectors. So that means like there is like the framework, or you can call as the method how uh, this vector will be matched with the different vectors. It's like it will try to find the nearest neighbors. So it will try to find out the nearest neighbors, or you can also call as approximate nearest neighbors. So you might be seeing something like HSNW, or yeah, like for example, right now we consider there is one method HSNW, which is an algorithm of the NNS. So what happens within this is like it will try to find the vector which is very similar based on the distance, or it can you can consider as a similarity. So first is what is the distance or what is the similarity. Let's say you know the Euclidean distance, like there are 2 points, and this tells about the distance of the 2 points. This is called a Euclidean distance. So similar way, if you are talking about the nearest neighbors, then you will be talking about the ne- how how much far the each vector is present to one vector. Let's say this is A bar, this is B bar. How far these both are. So how far in the terms of magnitude and direction. If you are talking about the similarities, right? Similarity, the popular similarity is the cosine one. It doesn't deal about the direction, but it deals about the sorry, it doesn't deal about the magnitude, but it deals about the direction, how different it is. So basically, similarity is nothing but this is one popular formula for the similarity. It's very similar to distance, like one minus distance by maximum distance between two vectors. So less distance means more similarity. So that is what it is. So now so now you understand what is the distance and what is the similar, right? So based on the similarity or based on the less distance, it will try to find the all the vectors which is coming. Let's say we have mentioned k as a 5. That means using the nearest neighbors, it will try to find out the k 5 nearest neighbors. That means you will get from the list. I mean from the vector store, you will get out of 5 vectors that are very near to the user query. So this is how the vector search happens. But on the top of this, if you want to find or if you want to just re-rank the queries or re-rank the vectors which you fetch. First one will be the most relevant vector. Second one will be the less relevant than first vector. So if you try to re-rank this step, so you can re-rank by using there is a popular framework for re-ranking that you can call it as based on the quotient similarity. Also, you can re-rank it or based on the VM25, which means which is actually a process of I mean, it indirectly contains the TF-ID of another thing. So, this way, if you're trying to re-rank the vector store, right, or re-rank the vectors which are fetched, then you are doing a semantic search. Yes. So, basically, your semantic search is vector search plus re-ranking what you got in vector search. So, this is the slight difference between the vector search and the semantic search. And yeah, thanks guys. I think you understand uh, now what is happening between the vector search and semantic search. When you say semantic search, most people will directly tell and now it's tried to understand the context and it will give the popular result. So that's not the right way. First, it will try to do the searching based on the vector. Then it will try to re-rank based on the proper context. So that's how the importance is given to the first top five by the model which it's taking, right? So it will see the position of that particular retrieval vector. Then it will try to address the solution for the user query. So that's how this semantic search is a little bit important or a little bit more weight, have more weightage when you compare to the just the normal vector search. Uh, yeah, that's about this. And thanks guys. If you liking my video or if you're having any particular doubts or any particular things that you want me to tell in next video, please let me know so that I have something to tell and it will be really motivating for me too. Thank you so much.